So, replication lag is basically when your secondary databases are always behind the primary. It's like trying to keep up with someone who's running faster than you can walk.
But isn't that just a matter of network speed? If we had faster connections, wouldn't it sync quicker?
Sure, but even then, there are other factors at play, like transaction log size and how frequently you commit transactions. Plus, if you have a high write volume, it exacerbates the issue. The more data you're pushing through, the harder it gets for the secondaries to catch up.
What about using asynchronous versus synchronous replication? Wouldn't that help?
Absolutely. Asynchronous replication helps because it doesn't wait for the secondary to confirm before committing on the primary. However, this means you could lose some recent changes if something goes wrong with the primary server. Synchronous ensures consistency, but kills performance because everything waits for confirmation from both ends.
That sounds like a trade-off between speed and safety.
Exactly. And let's not forget about partitioning or sharding your data across multiple servers. This way, each shard handles less load and can replicate independently, reducing overall lag. Also, consider tweaking your buffer pool sizes or increasing the capacity on those servers to make sure they aren't getting bottlenecked.
But what about when you need to do major schema changes? Doesn't that cause big lags too?
Oh, definitely. Schema changes can be brutal, especially during peak times. You want to plan these during off-peak hours and maybe use tools like CDC, change data capture, to minimize impact. And don't forget to test thoroughly beforehand. Nothing beats a few late nights debugging issues after an update gone wrong. Speaking of which, there are several factors that contribute to replication lag. Network latency is a big one. If your primary and secondary servers are in different regions, the time it takes for data to travel back and forth can really add up.
Yeah, I've noticed that when we have our secondary server in another data center.
Exactly. Another factor is the write load on your primary server. High write volumes mean more data needs to be replicated, and if the secondary can't keep up, you get lag. We also need to consider the processing power and memory of the secondary servers. If they're underpowered, they'll struggle to process all the incoming data efficiently.
Makes sense. Well, what about disk I/O?
Disk is huge too. If your disks are slow or overloaded, writing replicated data will take longer, leading to increased lag. You might want to look into SSDs or other faster storage solutions to mitigate this issue.
That's good advice. What else should we watch out for?
Well, configuration settings play a role as well. Things like transaction log size, batch sizes for replication, and how often you flush logs can all affect how quickly data is propagated. And let's not forget about any network congestion or firewall rules that might be throttling traffic between servers.
Got it. Got it. So it's a mix of hardware, software, and network configurations.
Precisely. It's like solving a puzzle where every piece matters. Network speed, server specs, configuration tweaks, all come together to either help or hinder your replication efficiency. Absolutely. Now let's talk about measuring and monitoring replication delay effectively. One of the best ways is to use built-in tools provided by your database system. Most modern databases have features that allow you to track replication lag directly.
Right, like MySQL's show slave status command.
Exactly. That command gives you detailed information including seconds behind master, which is a direct measure of replication delay. For PostgreSQL, you can use pgstat_replication to see how far behind the replica is from the primary.
How about setting up alerts?
Setting up alerts is crucial. You can configure monitoring tools like Prometheus or Nagios to trigger alerts when the lag exceeds a certain threshold. This way, you can catch issues early and prevent them from snowballing into bigger problems.
What other metrics should we be looking at?
Besides seconds behind master, you should monitor write throughput on the primary server and read throughput on the secondary. Also, keep an eye on network traffic between the servers and any errors or warnings logged in the replication process. All these metrics combined give you a comprehensive view of what's happening with your replication setup.
And what about logging?
Logging is essential for troubleshooting. Make sure you have detailed logs enabled so you can trace any discrepancies or delays back to specific events or transactions. Regularly reviewing these logs can help identify patterns or recurring issues that might be causing lag.
Sounds like a robust approach.
Definitely. With proper monitoring and alerting in place, you can proactively manage replication lag and ensure your secondary databases stay as close to real time as possible. Speaking of which, let's dive into how network latency impacts replication performance. Network latency can really wreak havoc on your replication process, especially if your primary and secondary servers are geographically distant.
Yeah, I've seen significant delays when the servers are in different regions.
Exactly. High latency means it takes longer for data to travel from the primary to the secondary server. This delay accumulates over time, causing the secondary to fall further behind. It's like trying to fill a bucket with a leaky hose. The slower the water flow, the harder it is to keep up.
So, what can we do to mitigate this?
One approach is to collocate your servers within the same data center, or at least within the same region. This reduces the physical distance data has to travel and minimizes latency. Another strategy is to use more efficient compression algorithms for data transfer, which can help reduce the amount of data being sent over the network.
That makes sense.
Also, optimizing your network infrastructure by using higher bandwidth connections or dedicated network links can significantly improve performance. And don't overlook configuring your replication settings for optimal batch sizes and intervals that balance between minimizing lag and avoiding overwhelming the network.
It seems like a combination of location, optimization, and configuration is key.
Absolutely. By addressing these aspects, you can minimize the impact of network latency and ensure smoother replication performance.